Have you ever considered the possibility that an asteroid may one day do catastrophic damage to the Earth? Whatever your reaction, some of the most brilliant minds working today are finding ways to assist humankind in surviving such a catastrophe. Elon Musk is among them and is making his own efforts to protect humanity from such a disaster. On the other hand, NASA has been considering the same issue and has even warned about the potential asteroid crash in space. NASA is developing a technology called DART to prevent this from occurring. How will NASA utilize DART to prevent asteroids from striking the Earth? What is DART? Asteroids are massive space objects popular in movies for causing chaos when they impact Earth. But is it possible for asteroids to hit Earth? To correctly answer the question, it is necessary to have some in-depth knowledge about asteroids. Asteroids are rocky objects that orbit the Sun, but are too tiny to be classified as planets. There are millions of asteroids ranging in size from a few feet to hundreds of miles wide, often called planetoids or minor planets. All asteroids combined weigh less than Earth's moon. Most asteroids are found in 3 areas of the solar system. Most asteroids are located in the vast ring that spans Mars and Jupiter's orbit. More than 200 asteroids bigger than 60 miles, 100 kilometers in diameter are found in this belt. According to scientists, the asteroid belt includes between 1.1 million and 1.9 million asteroids more than 1 kilometer or 3,281 feet in diameter, and millions of smaller ones. However, only some objects in the main belt are an asteroid. Ceres, for example, was once assumed to be an asteroid but was later discovered to be a dwarf planet. In the last decade, astronomers have also found a new object known as main belt comets, which are small rocky objects with tails. While some tails emerge when things collide with an asteroid or asteroids disintegrate, others may be comets in disguise. Asteroids are prehistoric objects. They are relics from the creation of our solar system 4.6 billion years ago. Early on, the formation of Jupiter prevented any planetary bodies developing in the gap between Mars and Jupiter, leading the small objects that were present to collide with each other and disintegrate into the asteroids we know today. Almost all asteroids are irregularly shaped, though a few of the largest, such as Ceres, are roughly spherical. They are frequently pitted or cratered. Vesta, for example, is a massive crater 285 miles or 460 kilometers in diameter. Asteroids rotate in their elliptical orbits around the Sun, sometimes tumbling quite erratically. More than 150 asteroids are known to have a small moon companion. Some of them even have 2 moons. There are also binary or double asteroids in which 2 asteroids of roughly equal size orbit each other, and triple asteroid systems. Near-Earth asteroids, or NEAs, orbit the Sun roughly the same distance as the Earth. These objects are classified depending on how the asteroid's orbit compares to Earth. Armor asteroids, for example, have orbits that approach Earth's path but only travel between Earth and Mars. Although Apollo asteroids have Earth-crossing orbits, they spend most of their time outside the planet's path. Near-Earth asteroids are also classified as potentially hazardous asteroids, or PHAs. These rocks are larger than 500 feet, or 140 meters across, and come within 4.65 million miles, or 7.48 million kilometers of Earth's orbit. Scientists have discovered over 27,000 near-Earth asteroids. Just under 10,000 of these have diameters greater than 500 feet. So, are we in real danger of colliding with an asteroid? The quick answer is yes. Asteroids and comets have routinely collided with Earth since its formation about 4.5 billion years ago. An asteroid larger than a quarter mile in size has the potential to cause a global disaster. According to researchers, such an impact would create enough dust in the atmosphere to effectively create a nuclear winter, severely disrupting agriculture worldwide. Smaller asteroids have a potential to destroy cities or cause devastating tsunamis. Smaller than 82 feet or 25 meters, space rocks will most likely burn up as they enter Earth's atmosphere. An asteroid collided with the atmosphere over the Russian city of Chelyabinsk in 2013, causing a shock wave that injured 1,200 people. When it entered Earth's atmosphere, the space rock was thought to be about 65 feet or 20 meters wide. How can we protect the Earth from a dangerous asteroid strike in the future? Or are we helpless, waiting to see how much damage an asteroid on course for Earth will cause? Elon Musk has proposed turning Mars into a habitable planet. He believes that a portion of humanity should begin to live on Mars in the event of an asteroid collision that wipes out humanity. He believes a community of 1 million people on Mars could be self-sufficient. He is even constructing a spacecraft to transport his volunteers to Mars. Musk's plan requires billions of dollars in incredible technological advancements. While Musk's plan involves avoiding an incoming asteroid, NASA's solution involves fighting the asteroid as it approaches. DART, or Double Asteroid Redirection Test, is the solution. How does DART work? On paper, it appears to be simple. Sometime in late September or early October 2022, the 1,210-pound or 550-kilogram DART spacecraft was slammed into a small asteroid named Dimorphos, changing the space rock's orbit around its larger companion, Didymos. Astronomers will measure the effectiveness of the kinetic impact method of asteroid deflection, which NASA plans to use against a rock with Earth in its sights. This technique works incredibly well when used ahead of time because small nudges can add up to significant changes later. DART is the first space mission to test this or any other asteroid deflection technique. The DART probe launched from Vandenberg Space Force Base in California late on November 24, riding a SpaceX Falcon 9 rocket. The DART mission team members have checked out the spacecraft's barrier systems and its main scientific instrument, DRACO, or Didymos Reconnaissance, an asteroid camera for optical navigation. You have to bear with NASA and its abbreviations. DART is a relatively small spacecraft. Its core consists of a box barely a meter wide on all sides, with 2 rollout solar arrays that give the spaceship a width of about 12 meters or 40 feet. DART's electric propulsion system generates a flow of charged ions to create a gentle but continuous push. The DART spacecraft carries NASA's evolutionary xenon thruster commercial Next-C engine, developed by the agency's Glenn Research Center and the aerospace company Aerojet Rocketdyne. The Next-C is a solar-powered ion propulsion system that could be used on future spacecraft. It is not DART's primary propulsion system, as the probe travels toward the Didymos Dimorphos pair using 12 hydrogen thrusters. Next-C, on the other hand, will receive a critical in-space test during the mission. The spacecraft will loop around Earth multiple times using its electric thruster to gain the speed needed to escape orbit. From there, it will head to Didymos, possibly flying past another asteroid named 2001 CB21. The action will ramp up considerably as DART nears its target. 30 days before impact, DRACO will take its first images of the Didymos system. Those images will aid the probe in fine-tuning its approach to Dimorphos. A tiny Italian spacecraft called Licia Cube will be launched by DART 10 days before the collision to observe the collision's immediate effects. DART will collide with Dimorphos at a speed of about 15,000 miles per hour or 24,000 kilometers per hour, so those effects could be intense. The impact will occur when the Didymos system is approximately 6.8 million miles or 11 million kilometers from Earth. This is the closest the 2 asteroids will come to Earth on their elliptical path around the Sun, which is no coincidence. The timing enables researchers to observe Didymos after the collision with higher quality telescopic observations. Didymos was last disclosed to Earth in 2003. It won't happen again until 2062. Long after this, Didymos and Dimorphos will still be observed, not just from a distance. In a few years, the European Space Agency intends to dispatch a spacecraft called Hera to the Didymos system to examine the damage DART caused up close. Targets for DART that are particularly suitable with Didymos and Dimorphos. They are both relatively small. Dimorphos is only 160 meters across, or 525 feet across, while Didymos is only 780 meters across or half-mile across. However, as seen from Earth, they pass in front of one another. Dimorphos circles of Didymos appear to optical ground-based telescopes as a single point of light that varies in brightness. After DART's impact, the interval of these fluctuations will change. Furthermore, Didymos and Dimorphos need to approach Earth closer for DART to send them hurtling in our direction accidentally. Building DART cost $324.5 million, The creation of the spacecraft cost $388 million. SpaceX launch services cost $68.8 million, and operations and data analysis are anticipated to cost $16.5 million. DART will strike Dimorphos at a speed of 4.1 miles per second, or 6.6 kilometers per second. Dimorphos' orbital period should shift from 11.9 to 11.8 hours due to the impact, a difference of only 4.2 minutes. As a result, Didymos and Dimorphos will get a little bit closer. That is our video for today. We hope you like it. What are your thoughts on asteroids that might strike on Earth? Will humanity be ready when it comes? Share all of your thoughts with us in the comment section below. Well, that's all for now. This is Big Tech Media. See you again tomorrow. Keep in mind to like, share, and subscribe.